All right, guys, here's page 2 of your review. Starting off with physical versus chemical properties. Okay, so a chemical property is a property that can be observed while there's a chemical reaction going on. Okay, so you just really need to remember this list of examples. All right, so the first one is radioactivity. Second one is flammability. Remember, that's the one we used as our example in class. If you know that a piece of paper is flammable, you have to light it on fire to observe that property. The next one is reactivity, pH, and then corrosive. So all of those are going to be considered chemical properties. The next classification is physical property, and I want you to make a note here. These physical properties are the ones that are observed without changing the substance. So any property that's used to characterize matter and energy and their interaction. So examples would be color, boiling point, viscosity. Please remember that viscosity has to do with the thickness of the liquid. So if you took water and a glass of syrup and you poured them out at the same time, then the water would pour more quickly because it is less viscous. So the more viscous something is, the thicker it is. We have color as another physical property, density, and conductivity. Again, all of those things are observed without changing the substance. In letter A, this table here, we're looking at physical changes in states of matter. So our first one is melting. Always, go back to the water. It's easy to think about. Melting water from a solid to a liquid. Freezing is from a liquid to a solid. Evaporation from a liquid to a gas. Condensation is the opposite, so gas to a liquid. And then these last two, you probably want to put a star around. These may not be as familiar to you, but you do need to know that sublimation is a change directly from a solid to a gas. And an example of that would be like dry ice. So you've probably seen it around this time of year where it's Halloween and we have dry ice and it kind of gives this smoky effect. Deposition or crystallization is going to be from a gas directly to a solid. So an example of that would be like a snowflake. So up in the atmosphere, when there is water vapor that passes through a very cold segment of the atmosphere, it turns directly into a snowflake, and we get to stay home from school. Ha! Okay, so in this diagram, what you need to know is the difference between solid, liquid, and gas. In a solid, please notice that the solid particles are locked in place, and they form this lattice structure. In a liquid, the molecules are allowed to move more freely, and then in the gas, the space between the particles has increased, and we say that they're moving rapidly. Please note that the main difference between these is the space between the molecules is what is going to visibly change. Additionally, put a little circle around this guy, the energy also changes. Okay, all right, now next we're going to look at physical properties in terms of whether they're intensive or extensive. Intensive means that they do not depend on the amount. So it doesn't matter if I have a little piece of paper or an entire paper, it's paper, okay? So that's what it means by intensive. So examples of that would be density, malleability, which is the ability for metals to be kind of flattened, melting point, boiling point, conductivity, and viscosity are all intensive properties. Don't have to, it doesn't matter how much of it you have, it just matters what it is. Intensive, these do depend on the amount. So some examples are length, mass, volume, and weight. All of these came from this word bank right here, okay, in case you're wondering. All right, so the next one is an actual example of a question. Examine the following data table. And of course, we get all this data, but what's important about it is intensive versus extensive properties. So the question here is asking how many different substances are represented in the data? 1, 2, 3, or 4? Well, there's 4 different liquids that are listed, but only 3 are unique substances. Here's how we figured that out. What I looked at first was the density. Notice that the density of liquid 1 and 4 are the same, 0.93. Additionally, those two substances have the same melting point of -98. So since those two intensive properties match, liquid 1 and 4 both have the same density and the same melting point, therefore they are the same substance. So when those intensive properties match, you know you have the same substance. Okay, now for some density calculations. In the first one, density, first of all, is mass divided by volume. And this first question is asking us to determine whether or not the sample is gold. So we know the given density of gold is 19.32. So given the mass and the volume, we're going to plug those into the equation for step 1. So step 1 is calculate the density. D equals m over v. 57.3 grams divided by 4.7 milliliters will give us 12.2 as the density. Step 2, we're going to compare that to the given density from the problem. Now, since 12.2 does not equal 19.32, we're going to determine that this is not pure gold. In number 2, the density of aluminum is given, and we're asked to be able to calculate the volume. Okay, so here's where we're going to start. D equals m over v. Now, the unknown in this case is volume. So I'm going to circle volume, and that's the variable that I want to isolate. So first of all, it's a denominator. So I want to first bring it out of the denominator by multiplying. That's going to cancel. And what I do to one side, I do to the other side. Now, this leaves me the equation m equals density times volume. That's still not finished because I want to have volume by itself. So since volume wants to be by itself, I'm going to divide through by density. Densities cancel. And V equals mass divided by density. That's the equation that you want to use. Okay, so using that equation, V equals m over d, plug in your numbers and you get the answer of 3. Please remember that process. I have a feeling this is going to be on the DA. All right, the next one, you have 250 milliliters. That's a given volume. You are given a density, and you're asked to find the mass. Okay, so again, our D equals m over v is going to have to be rearranged to solve for mass this time. So to do that, again, I'm going to bring volume out of the denominator by multiplying. That's going to cancel. And mass equals density times volume. Okay, so when I do that, I'm going to multiply density times volume, and my answer is 195 grams. If you have any questions on this page, please make sure that you ask me during class. And if not, go on to the next video.